Hello, grade 11s. Trigonometric functions is a topic that started in grade 10, and for you to understand this topic well, we need to reflect on what you did in grade 10. And maybe you have forgotten what you did in grade 10 about trigonometric functions. So just to take you back so that we can introduce the grade 11 stuff on what you learned. In grade 10, you did basic graphs. You did the graph of y is equal to sine x. You did the graph of y is equal to cos x. And you did the graph of y is equal to tan x. So let's just reflect on these graphs a little bit so that we refresh your memory as far as those basic graphs are concerned. Now, for the graph of y is equal to sine x, you noticed that the graph has some strategic points. Negative 360 degrees, it's y is 0. At 270 degrees, it's positive 1. Negative 180, it's 0. At negative 90, it's negative 1. At 0 degrees, it's 0. At 90 degrees, y is 1. At 180 degrees, y is 0. And then 270 degrees, negative 1. And then 360 degrees, it's 0. So it is that you must know the shape of the graph and the strategic points the graph passes through. Also noticing that on the values of y, the minimum is negative 1, the maximum is positive 1. And also the period the graph takes to complete one cycle is 360, and then it repeats itself. So that's the basic graph for sine x. I will put the graph for cos x now. All right, we can see that the graph of cos x takes the same shape as the graph of sine x. What is only different are these strategic points, how the graph goes and where it passes by. So we can see that negative 360 is 1, 270, negative 270 is 0, negative 180, it's negative 1. At negative 90 degrees is 0. At 0 degrees is 1. And then the points move like that. So the shape is the same. The only difference is that the points where the graph passes by is different from the graph of sine x. But then looking at the minimum is the same, it's negative 1. The maximum is the same, it's positive 1. And also the period the graph takes to repeat itself is also 360 degrees, it is the same. All right, and then let's move on to the graph of tan. All right, you will notice that the graph of tan is completely different. When you did this in grade 10, you noticed that at negative 270. The graph of tan is not defined, and hence you have an asymptote there. Also, at negative 90, there is an asymptote. At 90 degrees, there is another asymptote. And then at 270 degrees, there is also an asymptote. Then the other thing that you notice is that at 45 degrees is 1. It's an important point that you need to take note of when you are drawing this graph of tan x. At 45 degrees it's 1. At negative 45 degrees it's negative 1. So these 3 points, they give you the shape of the graph of tan x. If you notice also, at negative 180 it's 0 degrees, negative 135 is 1, negative 225 is negative 1. That gives you the shape, and each time the graph approaches the asymptote. And then negative 360 is 0, negative 315 is 1. It gives you the shape of the graph. So it is the common thing throughout which you need to know for this graph as we move on learning these graphs. So these are the basic graphs that you started with in grade 10, and all the concepts are going to be developed on your understanding of these graphs. Now, in grade 10, after having mastered this concept, you also went on to introduce A, that is y is equal to A sine x, y is equal to A cos x, y is equal to A tan x. So I will remove this and come back to this, just the summary of what we have just discussed. Remember, the period we said is the length of the interval that contains exactly one cycle of the graph, and the amplitude, and the summary of the 3 graphs, basic graphs. We notice that this is how we write the range for the graph of sin x. Values of y, they are between negative 1 and 1 inclusive, and also for cos x. But for tan x, we saw that it goes to positive infinity from negative infinity. The amplitude is 1 for the graphs of sine and cos x, and then there is no amplitude on the graph of tan x because it goes to positive infinity from negative infinity. And we notice that the period is 360, and for the graph of tan is 180. Now in grade 10, you introduced A, and the effect of A, you summarized it as the value of A, ignoring the negative sign, represents the vertical stretch of the graph as well as the amplitude. So if you ignore the negative sign, you are only looking at the vertical stretch of the graph as well as the amplitude. So that means that the amplitude is only referring to the graph of sine and the graph of cos sine. So maybe just to take a stroll on that concept. if we look at the graph of sine x, just to bring that again, we know how the graph goes, the graph of sine x. So let's introduce a. So I will put the graph of y is equal to 2 sine x, and I'll change also the color. Alright, so this is the graph of y is equal to 2 sine x. We have said a stretches the graph. So the 2 is stretching the graph. Now the graph is having a new maximum value and a new minimum value. In another sense, we were saying when we put negative 90, we'll get negative 1. Now the negative 1 is being multiplied by 2. So it means now the new point is negative 90, negative 2. So that's what is happening on every point. So we are saying the A, ignoring the negative, it affects the amplitude on this graph, and it does the same also on the graph of cos x. It affects the amplitude. So the amplitude is determined by A for the graphs of sine and cosine. But then when it comes to the graph of tan, since it does not have amplitude, we are simply going to see a vertical stretch of the graph. So the green is the graph of tan, and then we are going to put the graph of 2 tan x. Y is equal to 2 tan x. I'll change the color to blue. So we can see the difference is that we have said for the graph of tan x, we have strategic points. We have strategic points. When we were saying tan 45 degrees, we're getting 1. But now, because we are multiplying tan 45 degrees by 2, it means that 1 now is being multiplied by 2. So the graph is now passing through point 45 degrees 2. So that shows that the graph has been stretched vertically. Even this side, the vertical stretch brings now this point here. Even this, it was here, now it's passing through these points. So that's the vertical stretch. That's the essence of A, just ignoring the negative. But then, if we put or consider the negative sign, what we are saying, if A is negative, then there is a reflection in the x-axis. So let's go back to the graphs and try to see the effect of A when it is negative. So I'll put the graph of sine x. Alright, that's the graph of sine x. Now let's take, now our A is negative 1. Let's see what is going to happen. So that will be negative sine x. I'll put the yellow color. So we see that this was the graph. And now, because we are multiplying the y values by negative. So when we are having positive 1 by this negative, then the point now is reflected along the x-axis. It was positive 1, now it's negative 1 at negative 270. So that is applying to all the points which are off the x-axis. So this is reflected to that, this is reflected to that, and then, so basically it's a reflection. That is what is brought by the negative sign. When we have a negative, then we know that it is the positive graph that has been reflected along the x-axis. So this applies to all the graphs, all the functions, sine x, cos x, and tan x. When you have a negative, the graph is reflected along the x-axis. If we check on the graph of cos x, let's say we are having the graph of 2 cos x. That's the graph of 2 cos x. If we say, now let's reflect this graph, what are we going to get? It's just multiplying the graph we have f of x by negative. So that will be negative 2 cos x which will be a reflection along the x-axis. Alright, even the graph of tan, if a is negative, it will also be reflected along the x-axis. Let's say we have the graph of 3 tan x, which is a blue one. And remember those critical points. At 45 degrees, it's now at 3, 0, negative 3, 135, 3, 225. So it's just knowing that the 3, what effect does it cause? What's the vertical stretch it causes? So let's just check also if we have negative 3 tan x. So we can see that this part of the graph is reflected to this part of the graph, and this is reflected to that. So if you are asked to draw, it might be easy to start with the graph of 3 tan x, and then you reflect the strategic points that will give you the graph. And it becomes very easy to draw the graph than to go for point by point. Alright, then after that you also went on to introduce Q in grade 10. And Q is the vertical shift of the graphs. So you notice that when Q is positive, the graph is shifted up. Here we are. The value of Q represents the vertical shift of the graph. So when Q is positive, the graph is shifted up. When Q is negative, the graph is shifted down. So that brings the changes on the range and the maximum and the minimum. So those are the things that are affected by the graphs. So we are saying if we take the graph of 2 sin x to start with, the graph of 2 sine x. And then we are now introducing q. So let's do the graph of y is equal to 2 sine x plus 1. All right. So here we are. The blue one is the graph of y is equal to 2 sine x plus 1. Now, what is the relationship between the graph of y is equal to 2 sine x and the graph of y is equal to 2 sine x plus 1? We are saying this is our q, which shifts the graph either up or down. But because it's positive 1, so the graph is shifted up by 1 unit. So the easy part is this. It is easy to draw the graph of 2 sine x, and then you just shift those strategic points. Remember, these are the strategic points that you are having for the graph of 2 sine x, and then now you are just shifting up each point by 1 unit. So this will come here, this will be there, this one it goes there, this one goes there, and then you can draw your new graph without having the trouble of trying to find the point by point. It becomes easy using the transformation of graphs. So basically that is how we interpret, or how you were asked to interpret these graphs in grade 10. So what the changes that are brought by Q here is that the minimum, it was -2. Now the minimum, because the graph has been moved up by 1 unit, the minimum is now -1. Also, the maximum was 2, but because the graph has been shifted up, now the maximum is at 3. So that changes the range. The range, that will be y. Y will be greater or equal to -1, but less or equal to 3. So the range is what is affected on the graph of sine and the graph of cosine. And also, you can write this as y is an element from -1 to 3. Now the amplitude remains the same. It does not change, because we have said the amplitude is determined by A and the positive part of A. The negative part will only bring in a reflection along the x-axis. So the amplitude is still 2. What you need to be aware of is the range, because the minimum changed and the maximum will change. So basically in grade 10, this is the basic information that you did, and then the other part of grade 10 will also look at it in the next lesson.